Welcome everyone to our Python class. In today's lecture we will talk about Python dictionaries. They are a specific type of data structure which let us store key value pairs. In some other language it's known as associative array. Maybe you have heard of map or hash map. Again, the primary idea is that we have some unique keys and we can very quickly extract the values associated with this particular key. Even if you have a very huge millions or even billions large dictionary, you will be able to very quickly access the values. So we've seen lists in Python which have an index, right, a numeric index, and of course if we have the index we can always pretty quickly get the specific value out by the index. And in this case, think of the index being something non-numeric. It could be numeric as well, but usually you will use strings. In fact, you can use some other things, but usually we'll use strings. So let's see about our materials. Materials are available at the following link. You can do the follow the lecture along yourself and play around. Of course, it's also available at this code repository. All of these links are available at our course page. So here are some links to official documentation on dictionaries, on unofficial Real Python, which is not a bad site at all, and also here is one from Google Python class as well if you want to explore some alternative venues. Okay, so again, so the key idea is we store a collection of keys which have associated values with them, and we can very quickly get by key A we get alpha, by key O we get omega. But again, these keys can be pretty much anything as long as it is hashable value, meaning usually this will be a string, but there's some other data types we can use. So okay, so that's all theory. Let's see about practice. How could you make a dictionary? We can make a dictionary. This is the most common way of using a curly braces, right? Very quick, right? Most common way of using a dictionary, of creating a new dictionary, right? And we can check its length. Of course, first I need to run the notebook because this is using Google server, not using my server here. And it should be 0. Hopefully it is still 0. Yeah, it is. So again, it is a type of dictionary again. So we need it when we want to store it some data where it's not necessarily an order by numbers, but by some other values. So the classical example will make a phone book. By the way, before I proceed, you can also dictionary. You can make it like this as well, right? Empty, and of course print also dictionary. Notice something when I print this, right? Alternative. So this is an alternative way of doing it. Again, so we have so when we print, we see curly braces. That strongly implies a dictionary. Although sets also use curly braces, right? So again, so alternative way of making a blank dictionary, right? Again, usually this is, since most programmers are lazy, right, we're using the short way, right? Okay, so let's make something, let's fill it up with something, right? I will maybe add my own number, right? So I'll have Jack and, right, this is from the official examples, but so I have my phone book, right? So I have Jack and Sape. So, well, again, we can overwrite, right? So what happens if the first question may be, what happens if we add a second identical key, right? I mean, you should not, again, idea is of course that these keys should be unique, but it will not be an error if we had another Jack here, right? But a Python dictionary only allows unique keys, right? It's a specific structure. So what will happen, the Jack will be the last. Jack will have the 900 value. Okay, of course Guido will be the creator of the Python, right? I'll add his phone number, right? So basically I say tell, that's my dictionary name, square brackets, just like in a list, but instead of number I say, okay, here is a a new entry. Well, actually it will be, so we can see now, we'll print the keys, we'll print the values, right? I'll add myself as well, why not, right? So let's check. And also, so now our dictionary is pretty big, right? So a common question is, what do you do if you have more than, if you want to store more values than just one numeric value here, right? Well, there's no restriction of storing something more complex. I can have a list, so I can store a list of numbers as value in my dictionary against some specific key, right? It's completely normal, right? What's maybe not so great is that we have different data types. I'm storing numbers as value, I'm storing list as a value for this key. So it's kind of a little mismatch, but of course Python is built for that. It lets you do these very loose, because data often is not very tidy, right, in real life. So you're working with different type of data, like especially if you have something coming in from JSON, some really rough JSON file. Well, the Python dictionary will be quite useful, right? So how else can we make a dictionary? Well, I could use the telephone list. Jack have pairs inside, so you can see this. If I had this type of telephone list, right? I mean, it is possible, right? How could I make it a dictionary out of this? Can I make a dictionary? Yes, I can, but this is a list, right? This is a list of lists, a 2D list, right? So 2D list, right? So it's not, if I want to find Valdis, right, I need to go through each item. What phone number for Valdis? I have to go through and basically check every entry, which is going to be slow. Checking for specific entry will be slow, right? Unless I know the index, right? However, I could transfer this to a dictionary, new dictionary from tel list, right? Long name. So I could do dictionary tel list. Let's see if this works. I'm pretty sure it works, but let's see. Dictionary from tel list, right? Yeah, okay, let's see if this works. It should work. Yeah, and it worked, right? So now I have, so that's where dictionary comes in. I can pass a 2D list, type of structure, with two entries, and create a new dictionary here, right? Could be quite useful, right? So again, by definition, as Python has many things, dictionaries are mutable, meaning we can change, right? They're mutable, unordered, right? Key is unique to a dictionary. And let's see also about storing and extracting some data. We already been extracting some data, right? And storing some data, right? So again, so we get value. Again, so the key part is, even in large dictionaries, we can get the value very quickly. And here it is. Here is a value for Jack. Thank you, Jack. And I can tell SAP's phone number. I can change. I can overwrite already existing value, right? No warning given, right? If you want the warning, you need to check first, right? So yeah, I did this, right? My phone number, right? Maybe you can do your own name here, by the way. It might be a good chance. Maybe add your own name to this dictionary, right? So how about this? Well, with capital V, right? This is, remember, this text is completely different from my name with a capital V. Well, so this should give me a key error, right? Because there's no such key, right? So of course, we could search Stack Overflow, but it would give us the same answer. So what we could do is we could check first for a key in our dictionary, right? True. Okay, that's great. How about Peter? Peter is. No, he's not there. Okay. So if I try to print, if I want to avoid this error, right? I would like to avoid this error. Well, I could do, since we already know some programming, we know some if, we have this construction, right? I could check for key. If my key is in a phone book, I will print it, right? And I print my 3 numbers. Okay, great. But how about if I change the key to not my key, something else, some junk data, right? then what will happen? This if will fire and I'll print no such key. Okay, maybe that's what we want to do, right? No such key, right? So if key is in my phone book, I print this, otherwise I print no such key. However, this type of operation, right? So type operation is so common. This type of getting value by key and not getting error is so common. Python has the above code shortened, basically has the above functionality built in, right? So it's called get, right? So I take my dictionary, press a dot, right? If I did this escape A, so tail dot, you can see all of these different methods which I can operate on my dictionary. So I can use a get method. So how does it work? So basically it will give me no errors. It'll give me the value but without errors. So if you don't want errors, even here, right, I can do by default, I can have none. If I have I don't have key, I have the specific non data type, right, in Python, null in other languages. So if I want to get a specific default phone number, for example, right, I could specify, right, and it's kind of funny, right, here I will have -6560. Why? Because this is of course not a string, right? Again, people sometimes forget about this, right? So Nevaldis, I'll have -657. So I probably want this. I probably want to get this, right? So I say, so this operation is get the value by this key if this key is not existent in my dictionary, right? You can think of dictionaries as a very simple database. In fact, there are specific NoSQL databases such as Reddit which operate very operate very similar as dictionaries, right? It's a very powerful data structure actually, right? So we have a get, so we have no such key, and we have this default value. Okay, how about removal? Well, that's maybe less often, but yes, I could of course overwrite, right? But I could delete it, right? So it's possible. So I can delete. A specific key, right? Of course, will I have an error? Well, I won't, because I am always making one. If I didn't, right, it would get an error. If I did this again, tail sape, right, I would have an error. There's no, this will be an error. Let's check. Yes, key error, right? So for deletion, we would need to check first if the key exists, right? No get alternative, right? So there's no way of there's no built-in delete if it exists, right? So delete gives you an error if you want to delete a non-existent key. Okay, that's just an implementation detail. Okay, so yeah, of course I could check, right? There's no sape, no such key. Okay, so I could do val this in, right? Also, yes, usually we use it is basically the same as val this intel, right? That's what actually it is, because so it's a shortcut basically. When I say my dictionary, what I'm really checking is keys, right? So this will be fast. Again, one thing is, how about values? Yes, I can check if a certain value exists, right? However, this sort of defeats the purpose of dictionary. Well, meaning the access will be slow because it has to go through all of the values and check if that such value exists. Keys, however, checking for keys is extremely quick. So this is the idea. So basically, what's happening underneath for each of these keys are hashed basically on, well, a numeric index is generated basically underneath. But that of course is a more of a computer science data structures course which would explain that how actually it works. But you don't have to know about it, right? We just have to use it, right? So we have access. The main thing is that keys access is extremely quick. So checking for values, we can check if it exists, right? Again, so what is this values? It is a very specific type of type of dictionary values. Interesting. Well, we can print it, right? So again, tail keys, right? It is a dictionary keys, right? But it's certainly they both of these look like, again, they certainly look like lists, right? Wouldn't you agree? They do look like lists, right? So we can always compare them, make them my keys, my key list, right? I can simply call list tail keys if I really need to. If I really need to, right? I can always make it like this on my key list, right? My keys list maybe would be better, right? Jack of all this, right? And how about this one? My value list is of course going to be list tail values, right? And so this will be my value list, right? Come on, Google is slow, but right. So I have my value list, and again, notice it has these two values, and this has a list inside. Okay, so right, it's a specific type. We can do, of course, directory. What we can do is just a specific, very sort of like a list with some extra things, right? So like I did this here. Oh, I already did it. So we can of course count, right? Dictionary values doesn't have it, so we have to convert it to list to do something, anything useful. And what else? Right. So let's check key police value. Very common idiom is we want to check if something, right, and we want to add it, right? If key is not in a phone book, right, we want to add it, but otherwise we don't want to add it, right? So, well, so we add this new police key, right, and we have 911, right? However, this above code, again, there is a built-in method called setDefault. So what this means is we can put the phone number to our university right here, RTU, right? However, the kind of funny thing is, right, it will give me RTU, right? So if I give it another operation, I'll make a copy of this, right? Right, escape B, right? And I'll have maybe all 9,000, right? Maybe 9,000, you know, 9,000, 9,001, for example, right? This will not change. So if it already exists, RTU number exists, it will not change. Notice, right? It stays the same. Why? Because this set default. It checks. It's like this, basically this type of code. It checks if the value exists, if the key exists. If key is not in my dictionary, it adds. Otherwise, it just skips. So that's basically what this set default does. Okay, so we have set default. What else do we want? Well, again, we can delete keys if we want. We can get my phone numbers. What else would be useful? We can sort the keys, but so the question is, can you, well, since can we get keys outside in a specific order? That might be an important question. Well, since Python 3.7, the keys are given in the order you inserted them, right? So so my tail keys, right, would be Jack, Guido, Valdis, Police, RTU, right? Well, if I want them sorted, I could do this. I could do tail keys, right? Guido, Jack, Police, RTU, Valdis, right? So I could use this. Of course, this is not free, right? If you have a big keys dictionary, right, with lots of keys, the sorting might take, well, it takes time of the sorting, right? Plus a logarithm of the number of keys you have, right? So quite a bit of, could take some extra time. But if you need it, this is a possibility. So we can create the sorted keys, right? So in fact, there is a sorted dictionary data type as well, right? In fact, if you're looking around, there is a possibility. There is a specific sorted dictionary as well, right? Less common, right? So okay, so we can see we can also let's see, for key and tail keys, we can have new keys, for example, right? But of course, it's not going to help us. But let's make a shop of dictionary items, right? So how do we loop through both? So I have dictionary of some, let's say, put some my inventory at some shop, right? Or maybe my wish list that I want to eat, right? So I will loop through all of them one by one, right? So basically, I call shop dictionary items. This is my dictionary, and I say item. So this means at each iteration step, right, I'll have a new key value pair. So order of insertion starting potatoes ending with chocolate, right, I will have a, print key value buying 8 kilos of potatoes, right. I have some, and I could do more. I could do more work on these two key, on this particular key value pair here, right. Okay, so how are we doing? Right, I could also loop through using just a key, so only key. So same as for key in shop dict keys, right? So if I know the key, of course I don't need get. Notice I mean no point in using get since we know the key exists, right? We are guaranteed, right? So there's no point of using so this is an alternative. So either you go through both, or you just have keys and then you maybe pick up the values as needed. I usually use this approach, but again, this is also a fine approach. Again, depends what you need, right? So for key in shop dictionary, right, I could, of course, right, go through this dictionary and add maybe 10, right? So I can add 10 values, and of course my collection has grown. If I do it again, it will do again, so I keep going, and my needs keep growing, right? So again, let's check, have a new list, new dictionary. So again, we'll go through my items, right? So this is a slightly complex way of doing if you want to create something more complex. So we're going to go through my original shop dictionary items. Right here, we'll start at 101, and I'm going to print what I have, right? Notice that the extra parentheses because I'm getting out I'm enumerating items, right? So this will be a bunch of these key value items. These are tuples, and index will be the starting with 101. Just some extra stuff. So what I'll do is I'll append all of this to my list, and otherwise I'll make an index to value. So let's see. Maybe slightly made up in. So notice the difference, right? So this is a list, two-dimensional list, right? With entries. However, this is a dictionary, right? So this is why I usually ask not to use numbers as dictionary keys. You can use it. So, I mean, this looks like a list, but it's actually a dictionary, right? 102, right? You can use numbers as keys. Right? So when should you use numbers as keys? Well, so numbers as keys would make sense if you have large gaps in your numbers, right? Say 5, 3, 5 maybe, and maybe then dictionary would be great, right? But if you have maybe if you have only a number of small index, maybe you want to use a small list. Maybe if you only have few items, maybe you want to use list, right? So if you only have a few items, maybe a list would be better, right? So what else? Right. So I can also do this new dictionary, right? And I can create a dictionary of dictionaries. I can create something more complex. I can create a dictionary of dictionaries, right? Like I said, so again, values can be pretty much anything. A dictionary cannot be key. Can you create a dictionary as a key? No, you cannot. Why? Because dictionaries are mutable. So anything which mutates will potentially not be a valid dictionary key. But values can be anything. So this is potatoes. We can say, again, this is extremely common when you're working with JSON type of data. You have this multi-level dictionary with dictionary. So potatoes have a value of dictionary, and the dictionary has ID 101, quantity 18, and so on, right? So this type of structure nicely nicely transfers, right? So let's check. I'll make it, right? So beats, right, will give me a quantity, right? So if I want to actually have the quantity, I have to go 2 levels deep. Beats, which will give me a dictionary, inner dictionary for beats. Where are my beats? Here, right? And quantity, which is a key the second key for the inner dictionary, right? So 33, right? Of course, if I wasn't sure, right, I could use two gets, right? Get, because if I was not sure if I have beats or not, then this would be a good approach, except still, this would give me problem. Probably here you probably want to have a, let's try this, maybe we have some time. If I did this, no beats, right? Sorry, no beats, right? So maybe I have bad beats, right? This will give you error. Why there will be error? Why? Because this gets me none. So does none have a get? No. So this will be an error, right? Attribute error. None type object has no attribute get. Why? Because this is none. So let's try something funny. Let's try. Can we use this? So give me an empty dictionary. Otherwise, getting none. So this should work. Yeah, this works, right? On no quantity, no such sheet. Nothing. Sorry, nothing. Right? So I get by default. If there's no key here, I'll have a nothing, right? And of course, so sorry, nothing. Right? Sorry, nothing. So this works. So trick to have multi-level nesting level get work. We give a dictionary as default. We give blank dictionary as default, right? So I basically said, okay, if there's no such key, give me a blank dictionary. So then you can use a second level get. Well, this is not very common, but you can use this trick. Yes. So there are other ways I showed you. You can use dictionary like this, right? In fact, we can notice I had my keys, right? I had my values, right? What do I have? New dictionary. Do I have dictionary keys? Did I have dictionary? Let me go back. Let's see. First, let's check our time. We have some time still. Yes, we are doing pretty good, right? So we're going through pretty quickly. So let's check our values, right? We have tail keys and tail value. Okay, we have tail keys, tail values. So this means that we can create diction out of those. Little trick. Say tail keys, right? And tail so tail keys, tail values. Okay, so we have tail keys, right? That's just a list. That's just an empty. Oh, why isn't it there? Oh, tail keys maybe like this. Sorry. Like this. No. Okay. Well, I'll get it again. So I'll do tail keys. Here's okay. Again, I'll do it again. List tail list tail keys, right? On tail values, right, will be a list of tail values, right? And I can see tail keys, right? Tail values. Let's see. Yeah. So Jack. So of course these are exactly. I can go back, so I can deconstruct. I can deconstruct. I can also construct. And this is a little trick. I can make a new one, new dictionary, new tail dictionary. I can do dictionary, and I think it was. Let me see. Zip. Yeah, tail keys, tail values. Let me see if I did it correctly. I'm pretty sure this is correctly, but we'll see. Let's see. Will this work? No, I did. Oh, got 5. Oh, I think it was just zip. Yeah, just zip. Right. So basically, I zip them back. I can zip them back. Zip the two lists together. Right. And create a new dictionary. Right. Of course, I could change anything. So you can go back and forth. Right. I can use this to extract. Right. I can use this to extract keys and values. And I can construct and construct a new dictionary. Right, again, very common in data managing when you go from one to another. Right. So what else? Yeah, like I said, using tuples, we can create dictionary. So they're actually, interestingly enough, since we have some time, you can play around. There are some globals. What does it mean? This actually is a dictionary of what we are currently working on, right? Or current namespace, right? What we are working for, you can see globals will list all of the work we've been doing today, basically. Notice, it's like a meta programming, basically. We see, we are picking our own brain, basically, for the interpreter, right? We see all the globals, what we've been doing, all the entries we've been working on, right? So, So you can also check what variables are available, right? And you can see all these variables. Most of them are basically just hidden. So you can go inside your notebook and can sort of explore it. It's just mostly for sort of like, you know, think of yourself as a little hacker, right? But not very maybe useful in a general sense, right? So what else? There is lesser used value pop, right? Which if it doesn't exist, there's key error. I don't know when you want. It basically gives you the value and destroys. Similar how list pop also destroys the value in a list, right? So that will be used, right? And we can do something like this, right? 9000. No key found, right? Because I pop it again, so no key found. And what else? We checked we can put other dictionaries. Anything can be a value. Keys have to be specific ones. And well, that mostly covers the dictionary. So oh yes, we can add. Let's check our telephone book, right? We can do this, of course, right? Let's check our phone book. Guido Police RTU Valdis. Okay, we can update my phone number, Peter Seliga, right? So this is in place addition, right? So telephone book will be modified, right? Update method. And of course, notice I don't have my list anymore. I have a symbol number anymore because I was changed. It has changed, right? So Valdis is updated. Peter's, well, it is new. Liga also was new addition to our code. Right. Also, I can get a dictionary from keys. What else? The default, we checked the set default already. Yes, of course, we can always clear everything, right? Dictionary, let's say, or maybe telephone book, right? I'll do a telephone book and I have nothing no entries, right? Nothing, completely, and it's all gone, right? Garbage collector has collected all my phone book and it's gone, right? So let's for the conclusion, let's see how dictionaries can be used efficiently as a counter, right? So very useful thing, right? Much faster than using the count. So using it will import random. This is a random library for random functions. So I can count 4. Oh, it's always 4. No, it's 3, right? Is it always 4? No, it's always really a random number. Of course, the joke goes that the number, well, you choose it once and then you have a function and it returns a number. Well, we do want to have a specific, if you want specific order, if you want your numbers to be specific order, you seed them with a random number, right? So what we're going to do is we are going to create a list of random numbers, right? This is a list comprehension, right? We'll go through, right? Here indicates we do not care for the iterator index, right? We don't care about this number here, range, right? We only care about random numbers. So I have some random dice rolls. I'll do maybe, you can see maybe first 10, right? Right, looks okay. So let's check, by the way, is it minimum max? Min my randoms. Let's check if they're reasonable. Maybe make a mistake. Max my randoms. These are of course list functions, right? And randoms and maybe sum my randoms and divided by len my randoms, right? That's average, right? So 3.4. Well, okay, of course, the real average by the law of large numbers and statistics, you would have 3.5, but for 100 numbers, well, the deviation is not that bad, right? Okay, but let's count, see what's happening. So we have a counter, right? That's a dictionary, new dictionary, right? New blank dictionary, and we are going to count how many times this number approaches. So we check if we have this number, we add it, otherwise we indicate 1. So this might be very, very useful. Again, of course, we could have used an index, right? I could have used here, of course, here for numbers, from 1 to 6, I could have used the list as well, right, to count, right, to store my counts, right, counts. So, but it will be very useful to count words, for example, right? You'll see that later, right? So in fact, right, I could say, if I add some text, like maybe some lorem ipsum, right, my text, right, my text, and let me find some lorem ipsum, right, some random text, right, so lorem ipsum, right, and let me see here, right, I'll do some text. This is standard typography on web text, right, here I'll add it, right, and well, right, I could use it to split. So my words would be, of course, my words would be split, right, and my words, let's do first 10, sorry, equals, sorry, I can't type my text. Yes, so looks like, yeah, I have a list. I have my list, so I have a list. I get a list of words, right? So I will count these, right? So this is already turns out Python has batteries included, right? And counter is provided. It's provided already. It works just like what my code. So you can use, you don't even have to write your loop. You can use immediately this counter. So this will be, what is this result? What is this counter? It's like a dictionary, but with some, I like to say dictionary, but with benefits, right? So we can get counter, and we can get most commons, for example, right? We can get most commons. It's basically a dictionary, right? We can see 1s, 2s, 3s, 6, and so on, right? So I can always make it a counter out of this, right? So dice counter, I can make a dictionary. Okay, so I can make my count my words. My word dictionary, word count, I can do basically counter on words, right? And I can find the most common ones, right? Very cool, right? Most common, let's say 5, top 10 words, right? On why they can't my words, right? And I have the, of course, the is most common, lorem is number 2, right, and so on and so on. Quite useful, right? So this is so again, quite nice to have this type of result. Again, so going through, idiom for going looping is key value, and you can create dictionary. So if you want to create a new dictionary, there's an alternative. We can use something called dictionary comprehension. So all it really means is that we have some sort of looping construct right here, right? And we create new key value pairs. So this is key, this will be the key, this will be the value, right? We go through numbers from 1 to 10, and we have key value, right? So I could do this, of course, right? But I have square list, of course, right? List comprehension and list square dictionary. Notice difference, right? Well, what's the difference? You have key value. Here you have just values by index, right? So what else? Yeah, we can have dictionary of letters, right? We can enumerate a list of letters, and we can say letter I by index, right? Start 1 is K, and so on. Might be useful if you want to go through like this, right? Letter 10 is S, right? Notice how the keys don't really match the, I mean, it's not alphabetical, it's a lexicographical sorting. Okay, what else do we want to do? One last important thing before we finish is when you go through a dictionary, if you want to delete or add something, right, you need to use a copy, right? If you go through a dictionary, use a copy. Why? Because you should never modify, add. You can modify values, that's fine, but you should not add or delete keys when you're looping through. So use a copy, right? That's one way of doing it, right? You can use, right, right, if it's copy items, if v is delete, right, we have nothing, because remember I delete everything already. So you can also use update, right? So let me write it again. Oh, right. And I delete both of these. Okay. What's even better is, using list comprehension. We create a new dictionary by going through existing dictionary. You don't need a copy. I mean, it won't hurt, but it's not really not necessary here, right? You go through the original dictionary, telephone book, right? And we create a new one. So let me add something extra. Let's say add vowels quickly here, so we can see this, and I'll have my own number here, right? 2648, right? 2648, right? And so, right? On what will be the value delete 911, right? So these two will be new dictionary will only have my entry, right? Maybe I'll add my as well. So something maybe. Right? So update. So what will we have? Only my and Valdis remain. Why? Because in the new dictionary, those value to delete, right? We only added those which did not have. The new dictionary was created only from those key value pairs which did not contain the bad value, basically, right? So that's might be a very useful idiom or a approach to take. Either use this approach, right, or so this is top up, top down approach, or bottom up when we build up a new dictionary. I prefer usually to use this because this is much more convenient, unless chance you may override the old dictionary, because old one, right, will be, well, here I overwrote, but you could also have a new dictionary. So this might be something you to keep. If of course we could also do key, right, key to delete, right, and maybe key to delete, right, equals maybe Maya, yeah, and then of course, and a key not equal key to delete, right? So we need to check both, right? And if I do it, run it, only Valdis remains, right? Because I got rid of values, values to delete, and I got rid of key. So this might be an approach to use. Okay, hopefully this gave you a good introduction to dictionaries. We will discuss this more in our discussion session. And again, if you have any questions, go through the extra materials, extra links, again, shown here, right, for more information. Thank you, everyone.